Good evening. I hope we start joining in. So just setting up a few things. Good evening. I hope. Okay, so looks good to me. Cool, guys. So welcome again. So I welcome everyone to this live stream. We have been discussing about data science in general. So we started with what data science is. We started with artificial intelligence last. Today, we'll be talking about what are the different applications of AI and how this is going to be used in any industry. So that is prominently what the objective is. And we will be understanding how we can use this information going forward. Right. So that's pretty much what the agenda for today is. Just waiting for like a few more minutes so that people will start joining in. And the moment we are here, guys, just put a hi or hello in the chat. So as always, I'm monitoring the chat as well. So anything in general, so more than happy to discuss. So please feel free to drop in your text in the chat, guys. So I'll take up that. So just waiting for a couple of minutes. And today's agenda, prominently, as I've told you, is towards understanding of my artificial intelligence application. So what are the different aspects of data science on which we will be using uh, artificial intelligence on, and how this will be used for any of our purpose. That is prominently what artificial intelligence application will be covering next. So with this, I think we can kick off. Meanwhile, people will keep on joining us. Right. So to begin with, as always, my name is Arpit Jain, and the reason why I'm here because I love data science. That's my passion, and I really get excited sharing my expertise with people here. I like talking to multiple people. I like sharing my expertise. That is the pure reason I'm here. And talking about my profile, so I have been into analytics industry for quite some time now, into multiple fields, multiple domains, talking about telecommunication, manufacturing, automobile, cloud, finance, into multiple sectors, working as an analyst. And that is where I have been utilizing my skills in multiple sectors of data science. And that's the beauty of data science also, because being an analyst or being a data science guy, you are the person who is working on data technically, right? And data is everywhere, you know that. So be it any industry, any place, you will find the data. And that is where you get an invisible immunity that you can probably work in any field. And that's pretty much what I have done in my career. But for the past 4.5 to 5 years, I've been into telecom industry, currently working as a lead data scientist. And I have been working into multiple different skills. So that includes statistics, Python, machine learning. You can talk about deep learning, Spark computations, big data, group hive. So taking that problem statements from scratch and getting it running in the system. So that's pretty much I take care of the solution from end to end. Along with this, I'm also a motivational speaker, guys. So I do talk to students. I do take career mentorships. I kind of uh, like guiding students in terms of their career advices. So any questions in general, as well as I've said, please feel free to reach out. I'm always monitoring the chat. So it's pretty much a live session. So we will be discussing your questions here. Okay, so that's pretty much what the agenda and how and what I am. But going forward, talking about today's discussion, that is going to be prominently on the applications of AI. That is what the class will be focusing on. So, artificial intelligence, as we have been discussing, so it's not only about developing something really cool robotic machine for me. Okay. So we also talk about having a smart analysis which can still solve a business problem. So artificial intelligence, I would say, is again a bigger umbrella in which we can talk about multiple different aspects depending on the business scenarios what we are trying to solve a problem as. So artificial intelligence in general, also what comes in anybody's mind is like, okay, artificial intelligence more towards building up a right, nice drone or a nice robot which can, solve anything or do anything, whatever we want. Yes, that is absolutely one of the areas of artificial intelligence, but still, artificial intelligence covers a lot of other aspects where you have day-to-day business problems where you are seeing some kind of algorithmic approach coming up, again being part of my artificial intelligence. And that is what where we will be discussing about all of these different aspects or the applications of AI one by one. That is pretty much what the agenda for this video is, guys. So let's get started. Let's understand what exactly artificial intelligence is. But going before going forward, there's a nice quote for you. Artificial intelligence is nothing but a set of algorithms and intelligence. So we talk about set of algorithms and we talk about intelligence. So we're going to talk about both of these things to try to mimic human intelligence. Machine learning is one of them, and deep learning is one of those machine learning techniques. So, what exactly this means here, guys? A lot of different informations here. So, in general, artificial intelligence ultimately is a set of certain rules or certain algorithms, or I could say certain protocols through which we are trying to solve a business problem. And this business problem could be anything. This business problem could be like from a very generic use cases, healthcare industry. I want to detect whether the person has a cancer or not. It's a business problem. Whether the product which I am trying to roll out, whether that will be a success or not. Yes, it's a problem statement. Or whether any industry we can think of, whatever KPIs I'm tracking in any problem statement, whether that is going to be upright all the time or not. So depending on whatever industry I am in, whatever sector I am in, the business problem changes. So yes, a healthcare industry problem would not be same as the telecommunication industry. At the same time, a supply chain industry would be having a different problem statement, or a finance industry would be having a different problem statement. So problem statement could be anything. Problem statement could definitely vary from industry to industry, but ultimately at the end, what we are looking at is an algorithmic approach of solving that business problem. And that is where artificial intelligence comes into picture. So algorithm, by that I mean it's more towards finding out the right set of rules which can solve a business problem for you. And we also talk about intelligence. So intelligence to try to mimic my human intelligence. What exactly this is? So when I say human intelligence, so human can actually do lot of different things at the same time. I'm talking, it's a skill for me. I'm at the same time, reading the text, it's again a skill for me. I'm listening, I'm walking, I'm running, I'm doing a lot of other tasks. So this is again type of intelligence which is respective to humans. So I'm not talking about only finding out a cancer or only checking this whether this product will be a successful launch or not. So instead of pinpointing to a single problem, I'm now talking about lot of different things which can happen at the same time. So I'm not only discussing about a single problem statement here. I'm talking about multiple different things which can happen at the same time. That is where we talk about human intelligence coming into picture. And yes, there is an art, there is a method where in artificial intelligence, we try to mimic this intelligence of human, and we try to set up a machine which can do things which was expected from a human. Again, part of my artificial intelligence. So, as I was saying, artificial intelligence is a bigger umbrella. It talks about your day-to-day problems. It talks about the robotics in general. So, all of different situations and different problem statements which you can think of is pretty much comprising my artificial intelligence. So, artificial intelligence in general is a bigger umbrella here. Now, we talk about machine learning. So, machine learning again is one of those algorithmic approach to solve a problem, which is one of the types of artificial intelligence. So, machine learning is one of subparts of artificial intelligence. So, machine learning, that's where we understand the different algorithms for different problem statements. Again, these problem statements could be multiple. So we talk about having more of a supervised approach or an unsupervised approach. So we're going to be discussing about that as well. So all of these algorithmic approach, which we talk about, pretty much coming under my machine learning. Again, obviously, I cannot have the same algorithm for different problem statements, different type of problem statements. Simple. So the same logic, same protocol, same rules, same algorithm might not be applicable for two different problem statements. And that is where the machine learning, which is one of the sub parts of my artificial intelligence, comes into picture. So depending on the problem types, we generally sub-classify these algorithms as well. So in general, what we have observed is in machine learning, there are two subtypes of problems. In machine learning, we talk about two subtypes of my problem. So first subtype, what we talk about is supervised approach. And the second we talk about is unsupervised approach. We're going to be discussing about that in detail in our respective discussions as well. But just to tell you, because we're talking about the algorithms, we're talking about the skills, we're talking about the different methods which we have in which we can solve this problem. So machine learning is broadly subdivided into two types, where we have supervised approach and we talk about unsupervised approach. So how exactly even this things happen? So how do we write up supervised and unsupervised in my discussion? So what exactly we do in this? How do we work on supervised and unsupervised methods? So supervised, as the name suggests, we have some kind of supervision in this. Again, what is the supervision? So think about from a data perspective, the data, whatever data I have, I'm talking about some kind of relationships. We talk about the moment I have one pointer, which is like a set of information I have, set of features, and those set of features is ultimately correlated to my expected output. For example, suppose I want to say that what is the potential price of a house if the house is located in such and such location, having these many bedrooms, these many washrooms, or having this much of square feet area. So what not information? So considering all the other independent feature sets, my parameters, my columns, I'm ultimately trying to gauge what is the price of my house. So machine learning algorithms in which I have the target, the expected output also available in my data set, that is where we talk about a supervised approach. So I know based on these and these parameters, what is going to be my output? That is where supervised approach comes into picture. And again, supervised can be further subdivided into two types. We talk about whether this expected output is a continuous number, whether we say that it's going to be a house price or a salary of a person or whatnot, like a number, like a continuous number. That is where that supervised method is called as a regression technique. In regression, we have multiple such algorithms coming under my machine learning. The another subtype of a supervised approach is classification, where we say that the end objective is not a number, it's more like a class where we say yes or no kind of a situation, like a true false, 0 1, whether the person is having cancer or not. Yes, he's having cancer. No, he's not having cancer. Such type of problem statements comes under the classification types of my supervised. Both of these methods of classification and regression coming under my supervised approach has different set of algorithms which is going to be solving the respective problem statements. Likewise, we have the unsupervised methods as well. Unsupervised methods is the one where we talk about we don't have the expected output. Or think about a scenario where we have a customer base. So I'm talking about, say, an online platform. So any retail merchandise store on online platform, and I have a list of users who are kind of enrolled and who have logged into my system. They have their accounts in that online portfolio. Now, from the pool of all those users, we're trying to group them into different sections, saying that, okay, this set of people is having some X parameters, some X features in set in common. So I'm trying to group the pool of all users into smaller subgroups. This kind of approach, segmentation, we call about clustering approach. We talk about clusters, making clusters of my data comes under unsupervised. So broadly, my intention to talk about these is, so machine learning, here we talk about a single objective, whether it's a classification or a clustering or whatnot. We are still trying to solve one problem here, which is either finding out my class, finding out a price of my house, or finding out the right group for the customers. I am not doing anything else on top of this, which is where machine learning comes as one of the sub parts of my artificial intelligence, where I'm only focused towards solving one single problem. And deep learning is one of those machine learning techniques. So deep learning is again further subdivision of my machine learning, where we now talk about developing the similar approaches, the algorithms for a data which is being coming in the fashion of a table, like a rows and the columns, like an Excel file. Or even in some cases, we talk about data not being in the structure format like a table on the columns. I might have a data which is an image file. I might have data which is probably a video file or maybe an audio file. So all of these, like a textual information, we try to talk about my text analysis. So everything where we have something advanced coming up in the form of neural networks. We talk about neural networks here. So that is pretty much again a sub branch, a particular type of algorithms, a particular group of algorithms within the machine learning, which is designed to solve again certain set of problem statements coming under deep learning as a bigger umbrella. So if I have to draw it out, if I have to say how exactly things will be looking at in terms of my sliders. So what I can think is we have artificial intelligence, so which is more like one big umbrella for me. So my artificial intelligence is this. And inside artificial intelligence, we have again a smaller sub umbrella where we have machine learning. And inside machine learning, we have again a smaller umbrella which is deep learning. So artificial intelligence, and artificial intelligence, we have machine learning as one of the subtypes of my artificial intelligence. And under machine learning, we have something called as deep learning as well, which is certain group of algorithms. This deep learning is nothing but certain group of algorithms set to solve specific business problem. That is what we have in deep learning, guys. So we have artificial intelligence. Post artificial intelligence, we talk about machine learning. And post machine learning, we talk about deep learning. So machine learning is one of the sub branches of my artificial intelligence. And deep learning is one of the sub branches of my machine learning. So we all talk about these things where all of these are equally related, and we talk about them as and if when it is required. So I hope that makes sense. So with this, guys, I think you have a fair idea of what is artificial intelligence, what all things can be done in this, and where machine learning stands, where deep learning stands. So now let's try to understand the crucial two different applications of artificial intelligence and their respective business scenarios. So we're going to be discussing about that. So applications of AI is first broadly classified into a section called as narrow AI. So artificial intelligence is first broadly classified into something called as narrow AI, or narrow AI, also sometimes referred as weak AI. So this kind of artificial intelligence operates within a limited context and is a simulation of human intelligence. So what do we talk about here in terms of artificial intelligence? So we say that the narrow AI is the one where we have a limited context of things where we are trying to solve a problem. So we are not trying to solve everything what is there in front of us. Rather, we are focused on solving a limited contextual problem statement, which is again a simulation of my human intelligence only. But in terms of narrow AI or a weak AI, we are only talking about limited context of my human brain. So narrow AI is broadly focused on single task and it is heavily dependent on the given data. So in this case of narrow AI, we are broadly talking about solving a single task, not more than that. And this single task can think of multiple different objectives, guys, multiple different objectives. So broadly speaking, all the machine learning concepts or even the deep learning, which is anyway a sub part of machine learning, pretty much comes under the concept of narrow AI. Because if you think broadly, what are we doing in machine learning? What are we doing in the problems which we're trying to solve in machine learning? It's purely talking about one single problem statement. So be it a supervised method or be it an unsupervised method, We are trying to refer how these would be used eventually. So supervised methods, classification, regression, unsupervised methods, clustering, all of them has a specific dedicated work which is expected from it. So when I talk about weak AI, machine learning problem, think about a classification problem. So classification problem, when I say I want to find out whether the person is having a cancer or not, am I also checking what is the salary of that person? Or am I checking what is the age of that person? I'm only focused to find out whether the person is having cancer or not. Yes, to find out this information, I might be using a lot of interdependent things, but my end objective, my task is just one single task. I'm not talking about multiple tasks here. So whether finding out this person is having cancer or not, or whether finding out this customer will default or not, or what is the potential price of this house, or what is going to be the potential salary of this employee. So, or whether it's a classification, simple clustering technique, also like doing a customer segmentation or finding out two different products together. So, all of these is primarily focused towards one single task, guys, one single task. And yes, the moment we're talking about one single task, I am going to be heavily dependent on data. If my data itself is not able to identify the right set of relationship between this pointer and the other, then I'm not going to have a good model. I'm not going to establish the right set of trend based on which we can see a better performance. So if my focus is towards a single data, whether this data or task is to find out a person is having cancer or not. So to find out this objective, to find out whether the person is having cancer or not, in the before ground, I am actually having lot of corresponding data based on which the machine is able to identify some patterns. Again, if the data itself is not that reliant, if the data itself is not able to clearly distinguish the patterns, it could be of multiple reasons. Maybe the data quality is not that great, or maybe the data availability is a challenge, or whatnot. So it could be of multiple reasons. So for whatever reason, if ultimately I'm not able to figure out the things, that is where we could say it is primarily dependent on one single task. And again, yes, for this single task, we are going to be reliant on the given data. Okay, that is pretty much what we talk about in narrow AI. So all of these aspects of whatever day-to-day business problem you are thinking about, whatever you are seeing as an, if at all you are part of this, if at all you have seen certain use cases, problem statements in machine learning and stuff, that is where we have something called as narrow AI. We're going to be talking about the weak AI coming into picture. How this weak AI is now going to help us. That is pretty much what is expected out of this. So we talk about single task operation. We talk about only one single objective getting solved from this use case. And yes, it is going to be heavily dependent on my data. The moment we have not a great data, when I say a great data, the data where we don't have a clear distinction of my patterns, ultimately this task won't be a successful task for the narrow AI. It is going to be heavily dependent on my given data. The second and another very interesting part of artificial intelligence we talk about as artificial general intelligence, or something called as AGI. And this AGI also sometimes referred as strong AI. So the previous one was weak AI, and the current one we talk about as strong AI. So what really is the difference between my weak AI and the strong AI. So strong AI, where we talk about doing multitasking. I'm talking about we being a human, we are able to talk, we're able to run, we're able to play, we're able to sleep, we're able to hear, listen. A lot of things are there. We're able to see something. So all of these are some basic things. And apart from this, we are doing millions of things at the same time. So a human brain can actually perform multiple actions at the same time. We talk about multitasking, and that is where robotics comes into picture. So artificial general intelligence is the one where we say that it is going to be used in multiple subsectors of my robotics. So we are trying to generate more like a robotic scenario where we will be using this strong AI for one of the advanced purposes. And this is the place where we will be having the multitasking of my operations getting performed. So AGI, as I've told, artificial general intelligence is primarily focused towards the part of my strong AI. And this is we say the artificial general intelligence or the part of my strong AI coming into picture. So this is the place where we actually try to understand how exactly things would be varying in terms of multitasking. So how this is getting used into different subsectors. And that is pretty much what do we talk about as my strong AI here. So robotics is the very strong field. So robotics is the area where we know that the researches are still ongoing. So that is where now one machine is able to perform multiple things. So a robot can maybe walk or crawl or run or jump or do some multiple actions as well. Raise your hand. I mean, a lot of things. Just think about a human robot, right? And that is where multiple subtasking of my operations come. That is where the artificial general intelligence comes as strong AI. So both of these subsectors have their own respective importances. So the narrow AI is more intended towards solving day-to-day business problems, and those business problems could be from any industry, be it healthcare, be it finance, be it telecommunications. So as you can understand, all of these industries or sectors will have their respective problem statements which they're trying to solve. And at the same time, when I say artificial general intelligence is more towards robotics and mimicking my human brain, which can perform multiple actions together. So that is why we talk about weak AI and strong AI. So machine learning and eventually deep learning is pretty much falling under the category of weak AI or narrow AI. And robotics is pretty much under strong AI or the artificial general intelligence, which is prominently a research field. Cool. So with this, let's try to move forward and let's try to understand certain applications of weak AI, right? So how exactly weak AI would be used here in this case? So weak AI, where we understand in terms of data, there are certain use cases in which weak AI can be used. We talk about them one by one. So first is Google search. So very prominent use case, Google search, which we are doing every single day, guys. Trust me, Google search looks simple, but there are a lot of fancy different things available or happening behind the scene for the Google search. And what are these? So with the help of Google search, what you're doing, you are just typing some keywords, and based on those keywords, you are getting the relevant subsequent links available on your homepage within nanoseconds of time. So ultimately, what is happening here? whatever I'm typing in, whatever the input I'm giving, that input is able to get converted to a meaningful references, and based on those references Google is able to shortlist or filter out certain relevant links for you. So we in here we're talking about text. So whatever textual information we are writing up here, whatever textual things we are giving up to Google, it is able to decode it and find out the relevant meaning for you, right? So this is a very classic example of my language processing. In fact, if you would have realized, Google also accepts input not only in English, in multiple other languages as well. So we have language support system also in Google. So I can type up my query, which I want to search in my native language. I'll still get the similar relevant links. So how does Google do all of these tasks? So obviously, we can relate towards something called as text processing. So we're typing up some text here, right? And fortunately enough, those text is if we are able to get, I mean, the Google is able to get something out of those texts and ultimately giving us the relevant information. And that is where the concept of language processing or a natural language processing NLP comes into picture, text processing, and a lot of other conceptual parts also. It's not only about this, but think about the complexity, guys. You are actually typing in something and you're getting the result in nanoseconds of time, right? So Google is able to take in this input, run all the background checks it has to run, get the essence of this text, and then also able to map it to the relevant links, filter out the relevant links, show it to you on the page. And that is what Google search is doing in the background. So pretty much an example of narrow AI. Again, the objective is pretty simple. Whatever text I'm going to put in here, the similar text we are going to fetch in, and based on this text, we will be eventually having my output coming up here. So Google search prominently based on text processing, but again, a lot of different architectural things are still involved, but broadly coming under the part of narrow AI. Second is face recognition system. Very fancy problem statement, guys. Again, the objective is pretty simple. We're talking about only one single use case. We are not talking about multiple different problem statements. We are only talking about one single use case, which is getting used for my purpose. So in this case, when we say one single use case of my face recognition, so based on some video footages. So for example, I want to find out, I'm looking at, I'm maybe searching for a criminal or somebody across the streets of some city, and being from a cop department, I know I have the the flexibility to use my CCTV footages. So if I have the CCTV footages coming into as live feed, and I know my image of my person whom I'm trying to look at. So yes, there is a mechanism based on this. I can map this image from coming from my video footage, and I can identify, okay, this is who. So basically, from an image or from a video feed, I'm able to do a face recognition. It is able to tag, okay, this face belongs to person A, this face belongs to person B, and that face belongs to person C. Likewise, I can have thousands and thousands of such faces. Very crucial and very advantageous use case in cases of lot many sectors. Again, retail sectors are investing heavily on this face recognition system, and they're also building up a use case on top of this, where on top of a face recognition, we are also doing behavioral analysis. Once I've identified a person's face, now I'm also doing a sub-analysis on top of it. I'm trying to check what is the mood, what is the personality of the person, and how probable is that person to make a purchase in my store. All of these things are pretty much happening here as a face recognition, very heavily used now these days in security and infra areas. So face recognition finds its usefulness in multiple different sectors. Again, it involves one single objective. I'm trying to still, my objective still remains one only. When I say I want to find out who is this person, so face recognition, I'm not talking about what is this person's salary, right? I'm only talking about the recognition of this face. So my objective is still only one task at the same time. Yes, I understand the complexity involved. That is a different story altogether, but still pretty much falling under one single objective problem statement. That is where narrow AI comes into picture. Next, we talk about Siri, Alexa, and other personal assistants. Again, talking about my audio feeds now, like a Google Assistant or Siri or an Alexa. So all of these are nothing but my personal assistants. I can give a voice command and the machine is actually able to respond on those voice commands. So what is happening in the background, guys? This is something which is crazy. So my voice, my command is getting fed. These machines are able to take in these voice commands as an input. And these voice commands are getting processed, which eventually getting actioned upon. So when I give a command saying that, hey Siri, what is the weather tonight? Or hey Siri, can you play good music for me? Or Alexa, what is the current cricket score? So I'm putting up a question statement here, and this statement, my voice, is getting recognized by these machines. They are able to translate this voice information into textual information into the machine format, and that information, getting the intent behind this, you're getting a response from these machines. So again, the objective is pretty simple, trying to action on what my user input is. But again, pretty much coming under my narrow AI, weak AI. And all of these face recognition, Siri, Alexa, even the self-driving cars coming forward, pretty much everything here falls under the deep learning scenario where we have the unstructured data, as I was talking about. This can be used for the purpose of our prompt statement here. So use case here, when we talk about the voice assistants, Siri, Alexa, or any Google assistant, they are able to take up your voice command, and that voice command is where it's getting translated into the business, like a textual information, and then there's an action which is happening on top. Next, we talk about self-driving cars. So again, very interesting. So now these days, this is done. So we talk about self-driving cars. So these days, if you see in self-driving cars, many of the companies are heavily investing towards, again, this area of self-driving cars. So with the help of multiple sensory cameras located in and around the car, we are trying to develop a mechanism which can self-drive a car. We again talk about multiple different aspects here, but the end objective is driving the car. So self-driving of my car, where with the help of real-time processing of my live video feed. So whatever cameras are actually installed on my car, they are able to send in the video feeds on the real time, and these video feeds are processed together And depending on the outputs, the steering wheel and the other component of my behave, like a steering wheel, turning of my steering wheel, taking the accelerator, putting the brakes. So all of these things will happen automatically in self-driving cars. So where we talk about how exactly these things will be used for one individual purpose, which is still driving of my car. But this driving of my car is prominently dependent on lot of different input feature. And here we again talk about video analytics, image analytics, a lot of things are there where the self-drive comes into a picture. But again, remember guys, the end objective is still to drive the car, to self-drive the car. So coming under a classic example of narrow AI. At the last, we have any predictive model. So it's again a bigger umbrella here. So we talk about, for this case, ML algorithms. So ML algorithms again can be further subdivided into two types, which is supervised and another is unsupervised. And supervised is further into sub two types, which is classification. Second is regression. And unsupervised, this again we have multiple subtypes, but we talk about clustering, talk about associations here. When I say association, I mean suppose I'm in a superstore and person one bought milk. Yes, there is a high probability that if the person one has bought milk, he or she will probably buy butter or bread also, right? So that is where the predictive models comes into picture. So any predictive models, be it a classification type from supervised or be it a regression type from supervised or a clustering method of segmentation from my unsupervised or even the association rules, pretty much everything coming under my ML algorithms. So this is part of my predictive part or coming into the under the narrow AI. So how exactly this narrow AI is helping us to solve these predictive problems? A lot of algorithms, any predictive models can actually be solved using the machine learning technique. But here again in this machine learning technique, think about it. My objective is still defined. Whether it is going to be a classification of my results, whether it is going to be my regression of my problem statement, like finding out the salary, finding out every single thing comes under my predictive model, which is sub-top type of my narrow AI. So likewise, not only these guys, there are a lot of multiple applications of narrow AI. So we have just listed few of them. Lot of other functionalities, lot of different use cases also comes under my narrow AI, where the end objective is still to solve one single problem statement, not many, but one single problem statement coming under narrow AI. At last, we're going to talk about the advantages and the disadvantages. So, advantages of artificial intelligence here is it is very good for data heavy jobs. Obviously, the moment we have heavy data, the moment we talk about multiple different data sources, so we talk about velocity, we talk about veracity, we talk about volume. So lot of different aspects of data, how spread my data is, how what is the size, what is the volume, what is the frequency. So all of this comes under as a data heavy job. The moment I have a data heavy job, definitely artificial intelligence comes into picture, because here we do have the set of algorithms which can act on top of these. It obviously saves time because the same thing, if somebody starts doing manually, just think about the time complexity here, right? So machines, they are able to solve complex to complex of a problem in minutes, where a human being will take time to solve the similar problem. So obviously, it is going to save time in computation. Consistent results. So yes, we can have consistent results also. So a lot of functionalities can be used on top of this, but the same analysis, the same modeling results can pretty much be replicated n number of times. So we are going to get consistent results every single time. It is not again by default, but we can initiate this. And obviously dependent on the algorithm, so we can have the consistent results. Availability, pretty much available. So there is no hard and fast requirement as such here. So we talk about the availability of my artificial intelligence. So it's pretty much available, open to use. There is no costing involved as such when we specifically talk about the machine learning parts. So very helpful. So no issues or problem whatsoever in terms of availability of my things here. But like we talk about disadvantages, very prominent one disadvantages is it is very much infra dependent and hence it is expensive. So understand this, the moment I have a data size which is say 100 GB, do you think it is practically possible to process that file on your own local laptop, which is having say 8 GB or 16 GB of RAM? No, it is not possible. So the kind of problem statement we are trying to solve, it requires the respective infra or your environment on which you will be doing this artificial intelligence job. So that is very much dependent on my infra. And yes, the moment I am dependent on my infra, I will be expensive because an 8 GB laptop cannot be compared with what to say, a server of 100 GB processing speed, right? So all of this is some or the other way useful. So we talk about this in some or the other way. So pretty much infra dependent. We always talk about the things where we have the infra part coming up into picture. Very much infra dependent, and hence it is expensive. Also, it requires technical expertise. So the moment I say I have something coming up from the artificial intelligence side, so we need to have the right set of skills. So I cannot run, a layman cannot run an artificial intelligence program in any of these machines. So I need to have the right set of expertise required. And yes, we do talk about different skills, so those will be required. But again, it's pretty much where we have a disadvantage where we need to have a specific skill set on which we can be using artificial intelligence. At last, it is heavily dependent on my data because we're talking about the problem statements being solved. So if I do not have the respective data, I cannot find out the patterns. And if I cannot find out the patterns, how does it make sense? Right? So we need to have the data. It is heavily dependent on data and nothing beyond that. So that's pretty much what the AI talks about. So with this, guys, we are done with our today's discussion. So that is what I intended to cover. So key takeaways for you: two broad areas, two broad applications of my artificial intelligence. First is a weak AI or a narrow AI, where we talk about one single problem statement at one time. All machine learning algorithms, everything comes under here. Second, we talk about strong AI. That is where robotics comes into picture. That is where we talk about multiple different things now can be solved at a go. So that is where robotics comes into picture, and that is where the strong AI coming into there. And now in the subsequent classes, we will be going into these sections one by one in detail. Thank you, guys. So with this, we are pretty much done with our discussion. Thank you so much for being patient and listening to me. So I'm going to see you again the same time on next week. So let's meet each other then, guys. So we will be going in detail about these topics one by one. So any questions, anything, any last moment questions, guys, please put up your question in the chat. So I'll be more than happy to take that. Anything in general also, we can discuss. So I hope that totally made sense to everybody here. So let's keep on interacting. Any questions, guys? So we will be discussing that, but I think we are good for today. So anything, that is what the intention is. So we'll try to give you the information about the data science so that you can start thinking about it and planning about the things respectively, what are skills and how we can work on top of these parts. But likewise, we will be meeting each other every week and talking about every single new topic so that you have a clarity of how and what things are. Cool, guys. With this, I'm going to wrap up. Thank you so much. I'm going to see you the next week, same time. Thank you so much, guys.